Hello geometers and general seekers of truth. Welcome to the video lesson on solving for length inside of circles. And it's helpful if we start right off here with an example, given some information about these lengths. So BF here is 3, and I'll fill that information in a minute. DF is 8, FC is 11, and we want to find this length right here. Okay. Now at first, this can be a little bit daunting because one of the things that makes this problem difficult is that F is not the center of the circle. If it was, lots of things become much simpler. Okay. So the strategy of this lesson, the strategy of the day here, is to make similar triangles. Okay, so we're going to make similar triangles in this picture and use some proportions. And it can be a little daunting at first to figure out what to do. So when in doubt, just try some stuff and see where it leads you. And then if it doesn't lead you anywhere good, go back a few steps and try something else. So I'm going to start by connecting, let's see, B to D. Oops. Connecting B to D. And from this new connection, I have an angle B here, and if you notice, B intersects arc DC. Okay. So we know that angle B is equal to 1/2 the measure of arc DC, and this is a theorem that we've worked with and we've proved before in previous lesson. This is the measure of an inscribed angle. Okay, we call it the inscribed angle theorem. Now, what we want to do, since we're going to deal with similar triangles, we need to find angles that are congruent, and you want to find another angle that is also congruent to angle B. Well, that's not too difficult to construct, because if I were to make this connection here, you see that angle E, this angle here, is an angle that's inscribed and it intercepts arc DC. So the measure of angle E is also equal to 1/2 the measure of arc DC, and really for the exact same reason as what we have above. So from these two facts, we can say that B must be congruent to E, and this is really the reflexive property. Oh, I'm sorry, not the reflexive, this is the transitive property. Okay, so then we can mark these two angles congruent. So we know that these two angles are congruent, and we also have a very helpful result in the middle, that these two angles here are congruent because they are vertical angles. So EFC is congruent to DFB because they're vertical angles. So to finish this problem, we know that the two triangles then must be similar. Triangle BFD must be similar to triangle EFC by the angle-angle postulate. So if two sets of angles are congruent, then the triangles must be similar. And from here, solving our problem gets much more straightforward. So now I'm actually going to fill in the picture with the values that are given. So we know that BF is equal to 3, DF is equal to 8, FC is equal to 11, and we want to find EF. So we'll call this X. So now we're going to set up a proportion. So BF has its corresponding pair is EF, and that's equal to let's see, DF or FD over FC. Now these two results, the similar triangles and the proportion, I think your textbook calls it Theorem 10.14 if I'm not mistaken. But it doesn't really matter how we number the theorems. What really matters is what they say, and more importantly, what matters is that you can prove the theorem, or you can write the similar triangles so that you can solve the problem. So now we can make our substitution here. BF is 3, EF is X, FD is 8, and FC is 11. So this becomes an algebra problem. Multiply both sides by 11, you get 33. Multiply both sides by X, and you get 8X. And then solve 33 over 8 is equal to X, or 4.125 is another way that we could do it. So there you go, our final answer, and it really comes from recognizing where we might have congruent angles, and then using similar triangles, and then solving proportions. So congruent angles, similar triangles, and then using proportions. Okay. So I'm going to end this video here. You should try this next problem on your own before you look at the solution, and just so that you get a sense of practicing how to solve these types of problems. It is possible to solve this problem with the knowledge that you have already. You just have to kind of think about how do you make similar triangles in this particular picture. Thank you for watching, and have a wonderful day.